whatever I'm going to speak. Afterwards, I will be unmuting you if you'll have any doubt. Okay, no, because so many children would be speaking. First, what is kinematics? For that, I'm taking one example from, okay, one IIT asked problem. Okay, I'm taking pointer. Suppose winter season, people can see me. Okay. So, suppose winter season is there. You are traveling in a super fast train, early in the morning, foggy weather. Your driver of your train cannot observe that on the same track a bit ahead, a passenger train is moving. Listening to me now? When separation was a small distance d, you see here, when separation was a small distance d, you can see one laser pointed is indicating here. Then express train driver, which one was coming from behind with velocity v, had seen that on the same track ahead, a passenger train is going in the same direction with velocity u. V is greater than u. He became nervous. He had slammed the brakes. But train is not like our scooter or bike now, that you will apply the brake, it will be stopped. Train is moving. Separation is very small d. This super fast train here, super fast train had applied the brakes. Now, from this situation in your brain, what is the first question which is originating? Guaranteed, in your mind, the first question will come that whether collision will occur or not. The branch of physics which gives the answer of this very first question is known as kinematics. And after this, whatever in your brain, any question may come. How brake has worked? When brake is applied, how much distance your express train had gone? What is the mass of express train? How much retarding force has acted on express train? Because passenger train is going with constant velocity in this direction. Whatever is happening to this super fast train. So for finding the answer of this very first question, the branch of mechanics which gives the answer is known as kinematics. And after that, whatever question may come in your brain, the branch which you give the answer is known as dynamics. So kinematics, what is the cause of motion? Force. So in kinematics, we never study about force. We never study about mass. We are just studying about motion. This is already IIT asked problem beta. Here, if in distance d, if your super fast train will reduce its velocity from v to u, then there will be no collision. In traveling distance d, if the super fast train will reduce its speed from v to u, then there will be no collision. And kinematics will give the answer of this very first question. Understanding me now? Followed? So kinematics is that branch of mechanics in which we study only about motion of the body without considering its causes. We are not considering its cause beta. Cause of motion is force. Are you understanding me? Yes. Mana asked to unmute. I can't do. Yes, speak. I have
Sir, I
unmute.
forgot to put my hand down, sir.
Oh,
Before I.
I hope you understood that. Am I right now? Kinematics will be that branch in which we study only about motion of the body. We are not considering at all about cause. Cause of motion is force, so we'll not study about force, we'll not study about mass. Clear to you? I hope you understood that. है ना? Cause of motion is force, and we do not consider a study about mass and force acting on the body. Did you understand? And this diagram you followed? Yes. To solve this problem, we don't need help of dynamics. We are just needing kinematics. Clear? Now, we have various kinds of mechanics. We have Newtonian mechanics, Lagrangian mechanics, Hamiltonian mechanics, quantum mechanics, relativistic mechanics. We study the first mechanics, Newtonian mechanics, which is based on the concept of force. For the validity of Newtonian mechanics, there must be some assumptions. Under certain conditions, only whatever you are studying, that will be true. So first, I have written assumptions. In that first assumption is concept of particle. You see, such a big, okay, you see here, such a big van is moving. But if you want to apply whatever kinematics you are studying, you'll have to neglect the entire dimension of the system. You'll have to consider this van just as a particle. Okay, no? And see it is moving along a straight line path. That one we will tell later on. The first assumption for the validity of this Newtonian kinematics is we will completely neglect the volume of the system. We will consider only particle concept. So this is the particle concept. Total mass of the body, we assume that it is concentrated at one point. So a van is moving, a train is moving, a bike is moving. All these will be just particle for you. Volume will be completely neglected. Zero volume you will have to consider. Tell me, did you understand? I'm unmuting, and any child can say to me, have you followed it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Sir, yes, sir, understood, sir.
Yes,
Sir.
sir.
Yes,
Next,
sir.
Sir.
एकदम बेटा pin drop silence. You mute yourself whenever you will speak. At that time, only unmute, because from certain office, phone had come to me that please mute all the children. Okay, beta. So mute yourself whenever you want to say something. At that time, only you will unmute yourself. Now, second condition is very important, beta. For second condition, we to too much lesser than c, if v will be comparable to c beta, m will not remain constant. I remember a very famous example from Albert Einstein. A girl child for fun has asked, she was very lean thin. She asked from Einstein that I want to become a bit fat, what I should do. Einstein has told you start running. Okay, na? You start running. What do you mean by that? The famous Einsteinian relation, you know, this one I will give you in modern physics. M equal to m naught divided by under root 1 minus v squared by c squared. If your v will be comparable to c, m will be going on increasing beta. M naught is rest mass. For example, If V will become equal to C, then this quantity will become 0. 1 minus 1, 0. Root of 0, 0. Anything by 0 will become infinite. So when you will be moving with velocity of light, your mass will become infinite. Actually, according to Einstein's special theory of relativity, total mass will convert into energy. You know very well about black hole. The boundary of gravitational field of black hole is called event horizon. If any body, why not a massive star, planet, anything will come near to event horizon, black hole will pull it. Gravitational field is so strong that light also cannot escape. Very, very interesting. Suppose our Earth comes under the preview of, okay, no, or under the field, event horizon, it is reaching to event horizon, means the boundary of gravitational field of black hole. All of a sudden, it will attain velocity of light. The moment it will attain velocity of light, total mass will convert into energy, and that energy, okay, no, black hole will completely drink. Earth means including us, all of us will vanish. Each and every atom on Earth will convert into energy, and total energy black hole will drink. A question they had asked, if V will be equal to 0.866 C. C is velocity of light beta, you know. Very standard symbol, 3 10 to the power 8 meter per second. Pointer is on that. You can see if velocity of any body will be root 3 by 2 C, means 0.866 C, the mass of the body will be doubled. Little Hauser. Vs squared will become 3 by 4. 1 minus 3 by 4, root 1 by 4, it is 1 by 2. M will become 2m naught. I remember the question they had asked that with what velocity a body should move so that its mass will become twice its rest mass, and answer was root 3 by 2c, that is 0.866 c. So for the validity of Newtonian mechanics, mainly kinematics here, mass should not change. Mass will remain constant under only one condition, when V is neglected in comparison to C. So 10 meter per second, 20 meter per second, 50 meter per second, 100 meter per second, these can be neglected in comparison to 3 10 to the power 8 beta. So you are not finding any change in mass. But if you go towards fundamental particle like electron, proton, neutron, they are always traveling with tremendous speed. That speed of electron or proton or any elementary particle, you cannot neglect in comparison to say. So Newtonian mechanics, you cannot apply for those fundamental particle. It is other issue that we are applying it at intermediate level. Tell me, point 2, did you understand?
Yes, sir.
Sir, I have a doubt,
Yes, sir.
sir.
Assumption 2 is velocity should be so small that it is neglected in comparison to velocity of light, so that mass of the body will remain constant. Huh.
Sir,
Sir,
I'm having
1 minute.
when will
Vedant,
sir, when we'll move at the speed of light, sir, our mass will become infinity or our weight will become infinity, sir?
your mass will be infinite beta. Your mass will fully convert into energy E equal to mc square.
Okay, so that's what I have doubt, sir. It was mass or weight, sir. Okay,
There's
sir.
no question of weight beta, because the laws of physics
Gravitational field.
fails. The laws of physics fails at two places beta: black hole and for dark matter.
Sir, but weight, how can be, sir? Because weight is mass with the
Weight
gravitational pull,
weight
sir.
will become very, very large beta, because the G value is so strong When light cannot escape that gravitational field better, then what about any mass? There's no
Sir,
question of mass.
So
sir,
it
you
is
said that.
considered as
Sir, can
black
I
hole.
ask, sir?
Medhans, I had given answer to your question. Now,
Yes, sir.
now second boy to speak.
Sir, can I ask, sir?
Ask it.
Sir, so
Speak.
sir, you told the story, no, sir. Einstein will tell that girl to run so that her mass will increase.
That is for fun, he told.
Yes, sir. Means
With
if our
whatever
speed will
state,
increase, our mass will increase, sir.
beta.
Sir, if speed increases, even also if according to speed, mass also increases, sir.
Yes, beta. Yes.
Okay, sir.
But beta, any human being with whatever speed will run, that will be neglected in comparison to see. Okay, microscopic change will be there. Einstein has told for fun.
Okay, sir.
Sir, you said that black hole will grab all things, no, sir.
Yes, beta.
If one black hole will be side of another black hole, means what will happen, sir?
They will grow better. These two black holes, no, will first, I mean, it is already, they have found binary black holes. They will start roaming around each other and gradually they will become one and it will become a massive black hole. And a black hole is not a hole. It is a body having very huge density beta. Understood na? Gravitational field is very strong, so much strong that it is bending even space and time. It is just like any trampoline will be there na. On the net you keep in the middle a big ball. How it will, okay, no, depress there. Just like that, anywhere black hole is there, it is completely bending space and time both. So at this time, I'm not interested in speaking about that. I'm interested only in second point. If velocity will not be so small that it would be neglected in comparison to C, Newtonian mechanics will not be valid. For the validity of what you are going to learn, V must be too much smaller than C so that M will remain constant. Tell me, this point you understood?
Yes, sir.
Yes. Very good. Third point is my inertial frame of reference. That one you know very well. To express any vector quantity, you need a frame of reference. Already in vector chapter you have learned. Yes, frame of reference is of two types, inertial and non-inertial. Inertial frame of reference is that in which Newtonian laws will be true. Newton's laws will be valid there. Okay, no. So for expressing any parameter in kinematics, you need a frame of reference. It may be one-dimensional, it may be two-dimensional, or it may be three-dimensional. Whatever diagram I'm showing you here, you see the truck is moving along a straight line path. Now, if you want to apply, okay, whatever kinematics we are studying, first thing we'll have to do, this van, whatever you are seeing, it is ambulance actually, okay, you have to neglect the volume of this. I have drawn actually, you from the beginning, I will show you, you just see a straight line. After this, it will start. Yes, this is a straight line. If you take a particle, this particle will be going on moving along a straight line path beta. Am I right now? Then this is one-dimensional motion. If you vanish the volume of van and you take it just a particle, this particle will be moving along a straight line path. This is motion in one dimension beta. And because we will be learning projectile motion in too much detail, circular motion in too much detail, there I will show the videos of that. If you want, I will show you now also. It is possible, but because at present PPT mod, it is already there. So in projectile motion, I'll be showing you videos of all projectile. Your projectile motion or circular motion is motion in two dimension, means you need X and Y coordinates. you will have a frame of reference having x-axis and y-axis. For one-dimensional motion, you need only one axis. You can take it as x or y or z. Whereas three-dimensional frame of reference like landing or taking off of any aircraft, we are not studying at all. There will be some problems for IIT Advanced in that we will use that concept, but mostly we will restrict ourselves for one-dimensional and two-dimensional motion. So you need a frame of reference to study kinematics, maybe one-dimensional or two-dimensional or three-dimensional. Tell me, did you understand these assumptions?
Yes, sir.
Very good. So this video also you understood? Actually,
Yes,
beta,
sir.
this is
Sir,
actually beta, this video which you are seeing in this whatever uh, ambulance is there in New Jersey, my brother's hospital, they are taking the patient. So he has sent me this video. I thought, why not? Just a part I have taken out and I have shown you. Ekdam, because you see it is moving at the middle of the straight line. So I have taken it. See how the roads are there. Ekdam along a straight line, the middle of the road it is there and vehicle is moving at the center of that. See the line is visible. From height they have taken the picture. Is it clear to you? I have not taken from Google and all.
Sir.
Huh. This is from my house video. He had sent me this. Okay, in that only a part I have cut where it is a straight line and I have shown to you. This is one dimensional motion, but all these conditions. See, second condition is applicable, third condition already straight line is there. Only first condition you'll have to assume that when is not there, a point is moving. You see, a red point is moving. I will take just a point, we can apply kinematics because its velocity is undoubtedly very, very less. It is neglected in comparison to C. And frame of reference, one dimension is already shown to you. Take them straight line, they are showing you. Clear to you?
Yes, sir.
Very good, beta.
yes, sir.
Yes, sir.
I'm moving to, okay, number 2. Slide number 2 is in front of you. First, we'll have to learn about the parameters. Okay, now, yeah, we are learning about parameters which we are using in kinematics. First, distance and displacement. First physical quantity is coming. You'll have to learn. Already you know from childhood, distance is a scalar quantity, whereas displacement is a vector quantity. No need to explain now?
No, sir.
Okay. Now, second example, suppose you are in Madhapur and you want to go to Secunderabad station. There are so many roads. Through any road you go, whatever will be the length of the road on which you will travel, that will give you distance covered by you. But displacement does not depend upon which road you have taken. Different roads you take, distances covered by you will be different. But whereas displacement is concerned, it only depends upon initial and final position of the particle. So Madhapur you take as one point and Secunderabad station as second point, and just a hypothetical line you take to join these 2 points. Whatever will be the length of that hypothetical line, that will be displacement. And it is a vector quantity. So I have written displacement is directed line segment in between initial and final position of the particle. Are you understanding?
Yes, sir.
Yes, sir.
Now, I have taken one example with a very standard problem. Suppose I have a particle. I have taken this frame of reference. You know that without frame of reference, you can't speak about a vector. I have taken x-axis towards east and y-axis towards north. Okay, beta. Now a particle had moved 20 meter towards east and then 20 meter, okay, north 45-degree north of east means northeast direction, and again it has moved 20 meter. If anyone will ask, what is the distance covered by the particle? So it is the length of the path, 20 plus 20, 40. So distance covered is 40 meter, beta. The length of the path, you have written here, actual length of the path. The actual length of the path here is 20 plus 20, 40. Did you understand that?
Yes, sir.
But
Yes, sir.
Yes, sir.
vector quantity is depending, does not depend upon the path. It depends only upon initial position and final position. So this is displacement. It is directed line segment. So direction is from initial to final position. Now magnitude. So we will use vector addition. So many ways are there. You can use triangle law, you can complete parallelogram, then you can find resultant. Or other you take resolve component. I have taken resolve component beta. The first vector S1 means A vector is 20i. You see here 20i.
Yes, sir.
Now, second factor is again 20. But along x-axis component is 20 cos 45, along y-axis 20 sine 45. So vector B or S2, whichever you like to take, it will be 20 cos 45i plus 20 sine 45j. Yes or no?
Yes, sir.
Yes, sir.
Yes.
Resultant will be how much? 20i plus 20 root 2i. See here, and it doesn't have any j, okay, y component. Only second factor have y component. So if you'll add, it will be 20 by root 2j. So displacement factor will be 20 plus 20 by root 2i plus 20 by root 2j. So your S is how much? Sxi plus syj. So this is your answer. If you want magnitude, then mod s will be under root sx squared plus sy squared. Sx is this, 20 taken common, 1 plus 1 by root 2 meter, and sy is 20 by root 2. It is 20 by root 2 meter. Substitute here, you'll be getting the magnitude of displacement. Are you following me?
Yes, sir.
Here, all my children understood?
Yes, sir.
You'll have to take two things.
Yes.
You'll have to take a screenshot plus you know me, I always like handwriting. You'll tell why. When you're writing by hand, you are understanding in more better way, because the moment you are writing, your brain is working. Unless you will not understand, you'll be struck while writing. Am I right? A screenshot when you are taking the both you take. Why you have to do both? Because later on, if you will not understand, by seeing a screenshot, you can understand.
Sir, once explain B vector, sir.
Okay, beta. So I am taking pen and I will show you what is there in that. Suppose this is vector B. Okay, I will take red color. Why? I will take.
Sir, take white color, sir. It will be.
You want white color? Okay, beta.
Sir means we can see properly.
I have taken, this is beta vector B or S2, whichever you like. So it will have two component beta. This angle is 45 degree. This is mod B cos, if this angle is theta. You will be telling cos theta na vector you have learned so nicely. And this one is mod B sin theta na beta.
Yes, sir.
Yes, sir.
So B cos 45i, B sin 45j, B is 20. Cos 45 is 1 by root 2. So 20 by root 2. 20 by root 2i plus 20 by root 2j. Are you following me?
Yes, sir.
Yes, sir.
Hey, beta, just you give yourself 2 minute time, think, and then you see whether, oh God. Hmm. Okay, think, you will certainly understand better. In a hurried way, if you'll try to learn anything, you can't learn. So all my children, just be silent and let those children who didn't understand to derive by themselves. Spoon feeding, no, a child will never learn. If child will think, then only he will learn. Please see this and let him do. Let them do and let them calculate displacement. So displacement does not depend upon the path. It only depends upon initial and final position. Anyone will tell you define. It is directed line segment better.
Sir, displacement is 400 root 2 root 2. 2 plus.
What is the need of calculation? Already x component you got 20 in bracket 1 plus 1 by root 2 meter, y component you got. And you already know under root sx squared plus sy squared. So why to bother? Am I right? All my children?
Yes, sir.
Sir.
Okay, beta, just 2 minutes be silent. Let them, you people take a screenshot and copy it better. Handwriting always my personally, I prefer that only because a child remember whatever he is writing with his hand. Okay, so wherever it will be needed better in PowerPoint, I'll be giving you, these are the concept theory. So problems also I have written, but needs time better to prepare all this. Anyhow, write that better.
Yes, sir. Can you go to previous slide, sir? Previous slide, sir.
Okay, beta. You have not noted that?
No, sir.
Okay, beta. Take my screenshot, beta. If you'll be taking a screenshot, now the later on, if you have missed any point, you can by
Done, sir.
you can copy. Over.
Yes, sir.
Check this. Is it clear?
Yes, sir. Done.
Done. Actually, it is y-axis. North I have taken as y. Clear? I'm moving now to next. First, you note it because it is pure language. I'll have to explain. Completely noted, beta. I'll explain to you in too much detail all the 3 points. Completed?
Yes, sir. Completed.
Okay.
Sir, no.
Okay,
Sir,
beta.
we are writing, sir.
Okay, beta. No problem.
1 minute, sir.
Okay, beta. I'll give you 2 minutes. Once you complete, you tell me. It will become a good notes better to you. No need to prepare from different, so many books are there, you'll be confused.
Completed.
Okay, beta.
1 minute.
Okay, beta. Yes. No.
Sir, last point, sir.
Okay, beta. Right? No, don't be in a hurry.
Sir, completed, sir.
Okay, beta. You have completed now? You
Yes,
see
sir.
that,
Yes,
Completed.
sir.
you see that the third point you have, distance covered will certainly depend upon the path. When you go from here to Secunderabad, so many roads are there, beta. On different road, distance covered will be different. So it will depend upon the path chosen by the particle to go from initial to final position. Whereas displacement only depends upon initial and final position. It will not depend upon the path at all. Whereas, okay, so what will happen? Certainly distance.
No, sir.
Tell me.
Sir, so it will not depend upon the distance.
Yes, it will not depend.
Only between the initial and final points it will depend on.
Yes.
Okay, sir.
Is it clear to you?
Yes, sir.
Yes, sir. Clear.
So displacement will never exceed distance. Distance covered will always be greater than displacement. Only in one case, distance and displacement will be equal beta. And what is that case? When particle will move along a straight line path without return. Okay, no. If a particle is moving along a straight line path and is not returning back, then distance and displacement both will be equal. Are you following me?
Yes, sir.
Yes, sir.
A. Clear to you? But
Yes.
one thing more. Distance covered will always be positive beta. If you know that in motion, you can't go too fast. In Newtonian mechanics, always time will be going on increasing. So when time is going on increasing, if a particle is in motion, its distance will be going on increasing. So distance covered will always be positive. But displacement may be positive or negative, or it may be zero. Suppose you started from origin, you have gone towards positive x-axis, displacement is positive. Now you return back to origin, your displacement is zero. Now you are going towards negative x-axis, your displacement is negative. Did you follow?
Yes,
Yes,
sir.
sir.
So
Yes, sir.
displacement may be positive, negative, or zero in a given time interval.
Sir, when displacement will be zero, sir?
When you are starting from origin and again coming back to origin. From where you have started, again you come back to that point. You have gone from your house to school and again you have come back to house. Your displacement is zero.
Okay, sir.
Let
But then
you
positive and negative ones example.
Circle.
suppose I am taking origin. Particle is going along positive x-axis. Your displacement is positive. Now it has returned back to origin. Displacement is zero. Now it has gone in this direction, negative direction. This is origin. So now displacement is negative.
Understood, sir.
Understood, beta?
Sir, can distance be in upward or downward direction, sir?
Okay, yes, we can take upward, downward also.
Okay, sir.
Clear to you?
Yes, sir. Clear.
So
Yes, sir.
learning is different. I'm taking now slide number 3 is over. Now I'm on slide number 4. We are taking concept 1. Based on that, we are solving problem. Then we'll take concept 2. Based on that, we'll solve the problem. Okay, now? So first problem is in front of you. I have not given answer or key. Don't write it. Concentrate on problem number 1. And don't try to give answer. Give every child to think about it, then they will give answer. Whatever concept I have given, based on that, all the answers will be. 2 minute time you get.
Sir, can I say?
Hello, sir.
Yes, beta.
Sir,
Tell me.
got the answer.
Can we see answer, sir?
Tell me
Sir,
now.
The
sir, can we
Third option.
ratio will be.
Sir, third
No,
option,
C,
sir,
sir.
option
Option
C.
C.
First one is option C.
sir. Option C.
Option C.
option C. Very good, beta.
Sir,
You know,
because
Option
sir,
C,
can we,
sir.
sir,
Sir,
because
it would be
displacement
never.
can be negative and both positive, sir, but distance can only be positive.
Option
yes.
So
C,
if we
sir.
take both positive, it will be positive, and if we take negative, it will be negative.
Sir, and
Okay,
displacement is always less than.
It,
Yes,
yes.
sir. Displacement is always less
Displacement
than
will
this.
always be less than, okay, distance covered. Only in one case it will become equal when particle will move along a straight line path and it is not returning. In that case, distance covered and displacement both will be equal. So correct answer for this will be C. Okay, no, this will be the answer, beta, because they're asking you displacement by distance. So it will be less than equal to 1. Clear to you? All my children, all these students
Clear,
who
sir.
are there at this time, 106 children are sitting. What is the strength of your class?
Sir, 111, 888, sir. No, sir, 111 or 113.
138, sir.
The one,
Highest is a ones.
yes, sir, 140 approx, sir.
Yes, sir.
Class 128 were there, sir.
What? Beta?
Yes, sir. 130
Yes, sir.
approximately.
Sir, in maths class, 130 or 128 were there.
In the
Sir,
morning?
one time, sir, 138 was maximum strength, sir.
No, not that. I'm asking today morning how many children were there?
128, sir.
128, 128, 130.
So why the number is not there?
Don't know, sir.
Don't know, sir.
Sir,
Okay.
in that also, 3 are from this Narayana admin, sir. 2 are from maths sir devices only, and 1 is this host, Narayana admin host.
Sir, max 125 members will be there in each
Sir,
class.
approx
He's
130.
He is recording his own class.
Who, sir?
No, you are telling there are 2 from sir's name.
No, sir.
No,
will,
sir. Sir, from
connect
one
audio
device.
From one and
Yes, sir. From one audio and from another, he writes and shares the screen.
Sir, someone John Gion Con joined.
Okay, let him join. He will also listen. Okay, now. So now.
Remove him, sir.
I'll leave it.
No, sir. Sir, continue, sir. Again, it will take half an hour. Sir.
You
Leave it.
tell him to learn math. I'm not finding him here. So somewhere he will be. So now please go for problem number 2. A particle is moving in a circular path of radius r. Find distance covered and displacement of the particle when it completes 3.5 number of revolutions. Don't see solution. You understand and try to solve by yourself. Okay, no?
Displacement.
sir, displacement is 2r and distance is 3 pi r.
It is already on the screen. I am telling you not to see the screen. Just you take the question and by yourself.
Sir, R means number of revolutions, sir.
Haan, beta.
Sir, displacement 7, sir.
22 R is distance, sir.
Answer is distance
Displacement
covered
7,
is
sir.
22 R. Because right hand side you see I have drawn by hand only. Okay. In one revolution, distance covered is 2 pi r. In second revolution, it will become 4 pi r. In third revolution, it will become 6 pi r. And then half is there. So half is pi r. All you add, it will become 7 pi r. Pi is 22 by 7. 7 is cancelled. Knowingly, I have taken 3.5, so that 7 would be cancelled. So you got 22 hours.
Sir, mute Venkat Sai out of this.
Sir, mute yourself, Venkat sir.
Okay. So now total it becomes 22 r. Displacement is 2 r and distance covered is 22 r. Tell me, did you follow this?
Oh, sir. Yes, sir.
Yes, sir. Followed, sir.
Okay, let us children also
Yes, sir.
follow. हाँ बेटा. Distance covered is length of the path. So when you take length of the path,
Sir, mute him, sir.
when you take length of the path, in one revolution it is traveling 2 pi r. In second revolution 2 pi r. In third revolution 2 pi r and half pi r. So total distance covered is 7 pi r.
Hello, sir.
Answer.
Sir, I took like one revolution is equal to circumference of the circle, which is 2 pi r.
Yes.
Then 7 by 2 revolutions, how many? Cross multiply, I got 22 r, sir. Distance.
Take them right better. So your answer is displacement 2r and distance covered 22r.
Sir, how did you calculate displacement, sir?
You have
Can I
written
tell how
on
to calculate displacement?
Okay, 1 minute. Go back. Okay. You have written that. You see here. I'm taking pointer. See, you have written that displacement depends only upon initial and final position of the particle. So now I'm going back. Okay, here. So initial position is this, final position is this. What is this distance? This distance is 2r na. It does not depend upon the path.
That means r plus r, no?
हाँ बेटा, r plus r, that is 2r.
Yes, sir. 3 times will not be considered, no, sir, because initial and final positions will be same.
Yes, beta, you are right.
Sir,
my
will you... Hello, sir.
हाँ बेटा बोलो.
Sir, will you explain once more distance covered?
हाँ बेटा, why not? Particle started to move from here. One rotation. How much distance? Tell me.
2 pi r.
Now second one. How much distance?
4 pi r.
4 pi r.
Third revolution. How much?
6 pi r.
6 pi r.
Now sagam, half.
7 pi r, sir.
So answer is 7 pi r. Pi is 22 by 7. 7 cancel. You got 22 r. So you see here answer is 22 r.
Yes, sir, understood.
One laser
Thank you,
pointer is
sir.
moving on that you check.
Okay, sir.
Clear?
Yes, sir.
All my children
Yes, sir.
understood?
Yes, sir.
Break.
Yes, sir.
Very good.
Yes, sir.
Now I'm moving to next problem.
Sir, break.
Particle, don't see solution better. A particle moves in a circular path of radius r.
One
But
break.
radius vector subtends an angle theta at the center. Okay, no, you will be taking at the center. Anna, leave this, you take at center. Find displacement and distance covered by the particle. Okay, figure you take here. Okay, no, this is the figure. Okay, no, particle had moved from A to B. This is radius vector. Radius vector is subtending angle theta here. So distance covered will be the length of the arc ACB, whereas displacement magnitude will be length of the chord AB. Clear? Here I have taken theta 90 degree. That is a special case.
Sir, break.
Break. What is time now?
12:05.
Okay, better.
12:05, sir.
You need how many? 5 minutes?
Sir, continue class, sir. No
Yes.
need of break.
No, some children wants. Okay.
Sir,
Give 5
continue
minutes,
class.
beta, really 2.5 hours. 5 minutes I'm giving. Voice is stopped.
Okay, sir.
Sir, after the break, more problems you can do, sir.
Yes, you'll be doing more problems.